You hear it all the time, right? That AI is basically magic. But it's not. In fact, it's a surprisingly simple process, a loop that gets repeated thousands and thousands of times by a kitchen apprentice named Ming. Okay, let's dive in and break down exactly how it works. No code, no formulas, just one kitchen.
So, picture this. You walk into one of those fancy omakase restaurants. There's no menu, the chef just takes one look at you, nods, and then starts bringing out this sequence of dishes that feels like it was made just for you. How does he do that? How on earth does any chef know the perfect order of courses to serve a complete stranger?
Well, the answer to this mystery isn't magic. It's our apprentice, Ming. He's the key to this whole thing. And if we can understand how his kitchen works, we can understand the very core of how these large language models actually think.
All right, so let's meet Ming and get his kitchen set up. First things first, we need to understand the tools he has to work with, because his whole setup is, well, it's pretty unique.
Here's the scene. You've got a simple wooden counter for serving, a huge library of what he calls cookbooks, we'll circle back to those in a second, and then there's this one massive wall. I mean, floor to ceiling, just completely covered in these tiny little physical dials.
And there are a lot of them, 4,092 to be exact. Now, each one of these dials represents a tiny little piece of culinary judgment. Think of it like a tiny opinion, right? Like, how much should a seafood starter influence the rest of the meal? Or how important is texture? All 4,000 of those tiny opinions combine to create Ming's entire culinary intuition.
So what is Ming studying? Well, in those cookbooks, he has 32,000 complete omakase meals. But, and this is really the crucial point, these are not recipes. There are no instructions. They are just sequences. For example, a meal called Emma is just 4 courses. E, then M, then another M, then A, served in that exact order. That's all the information he gets.
And this is a brilliant way to think about why that sequence is so important. The same dishes in a different order create a totally different experience. It's just like words in a sentence, right? Direction is everything. And by just digging into thousands of these sequences, an intuition for the hidden rules starts to emerge all on its own.
But here's the thing. Ming can't really work with food directly. He has to turn it all into numbers. So each course, S, E, or M, gets turned into a number. But a number is just a label. To really capture the essence of the food, each one also gets a flavor profile card with 16 different slots for characteristics, stuff like richness, temperature, and texture. At first, these cards are just random noise, total gibberish, but as Ming trains, they'll become these rich, meaningful descriptions.
Okay, now for the main event, the training loop. This is how it all clicks together. This is where the real work gets done. Ming is going to repeat a super simple 4-step process over and over and over again to build his taste completely from scratch.
And the loop itself is beautifully simple. 1. Cook. He tries to predict the next course. 2. Score. He gets a penalty based on how wrong he was. 3. Trace. He works backward to find the specific dial that caused the mistake. And 4. Adjust. He just tweaks that one dial a tiny little bit. And then he does the whole thing again.
So let's break that down, starting with step 1, cook. You can think of Ming's brain as having 2 stations. The first is the round table. That's where he looks back at the dishes he's already served and asks, okay, what does history tell us? The second is the back kitchen. That's where he brainstorms and filters his own new ideas, asking, all right, what do I think about this? He puts those 2 perspectives together to predict the next course.
Now for step 2, score. After Ming makes his prediction, we show him the correct answer. The penalty he gets is all about how surprised he is. You know, if he was 100% certain the next course was A, and it was, great, no penalty. But if he gave A only a tiny chance of showing up, and it did, ouch, that's a big penalty. This is called the loss score, and the entire goal of his training is to get that number as low as humanly possible.
And right at the beginning, Ming's score is 3.3. To put that into perspective, that's the score you'd get if you were just randomly guessing. It's total madness. There is 0 skill involved. So that score becomes his North Star. Every single thing he does is about pushing that number down.
So Ming gets a bad score. But how in the world does he know which of the 4,092 dials to fix? He traces the error backward. It's like this. If a diner complains that a dish is too salty, Ming works backward. The salt wasn't added at the end. It came from the soy sauce in the back kitchen, which was added because of a suggestion from the round table, which was influenced by that one specific dial.
That's how he does it. He follows the chain of cause and effect all the way back to pinpoint the exact dial to adjust.
So Ming just repeats that loop: cook, score, trace, adjust, thousands and thousands of times. So what's the payoff after all that practice? Let's take a look.
After thousands of dishes, Ming's loss score drops from that chaotic 3.3 all the way down to 2.37, and that is a massive improvement. It represents the journey from just guessing randomly to developing something that actually feels like a refined culinary taste. He's actually learned the patterns.
But here's the part that's truly mind-blowing. He never memorized a single rule. Nobody ever told him, hey, don't serve 3 fried courses in a row. He just kept running that loop, and slowly but surely, the dials found their own groove. They just started to naturally reflect the underlying patterns in the food. That's the heart of intuitive learning.
Now, this pattern matching ability has a pretty funny side effect. If you ask Ming to come up with new dish names, he might say things like Korea, Yuran, or Leo. They sound totally plausible, right? But they don't actually exist in his cookbooks. He's just spitting out combinations that fit the pattern. And this is exactly what's happening when you see ChatGPT confidently make up a fake historical date or a source that doesn't exist. It's just a statistical intuition with no reality check.
So, we've seen how Ming's small kitchen works. Let's finish up by connecting this simple analogy to the massive scale of a real-world model like ChatGPT.
And the difference in scale is just staggering. Ming has about 4,000 dials. ChatGPT has hundreds of billions. Ming trained on 32,000 meals in about a minute on a laptop. ChatGPT trains on trillions of text sequences from pretty much the entire internet for months on thousands of super powerful computers. It's a completely different universe of scale.
But here it is. This is the most important takeaway of this entire thing. The cooking principles are identical. It uses the same stations, a round table and a back kitchen. It's the same fundamental loop of cook, score, trace, and adjust. The core process did not change at all. It was just scaled up to an absolutely astronomical degree. So next time you hear someone say AI is this mysterious, unknowable magic, just think of Ming. One apprentice, a wall of dials, and a simple loop repeated relentlessly. What comes out the other side isn't really intelligence as we think of it. It's a statistical intuition, one that's so refined and so sharp that it feels like a sixth sense. And all of it, whether it's spinning a story or breaking down a complex idea, comes from that one simple loop in that one kitchen. No magic tricks, just Ming.